Hi, everyone. My name is Chloe Alexander. I'm a senior in plant biology at North Carolina State University. And today I will be presenting to you my project that I did this summer at the NASA Kennedy Space Center in the Space Crop Production Program called the GAPS List Space Crop Production Interview Evaluation. So the Space Crop Production Program experiences many challenges when it comes to growing plants in space. In space environments, plants experience higher radiation, lower pressures, higher CO2 levels, hypoxia, meaning oxygen can't get to the root, no natural convection, meaning no natural air movement, and no gravitropic responses, meaning plants can't feel gravity and know which direction to grow in. Now, this is just a list of a couple, but there are many, many others. So it begs the question, how can we solve these issues systematically? In comes the GAPS list. Here at the top, you can see gap with all of its components. So the GAPS list is a list of hierarchically arranged issues or gaps. These gaps are attainable and they are lacking knowledge or technology in the program. So the first two divisions are gap section and gap category. We'll mostly be focusing on section here in this presentation, hardware, crops, and ecosystem. But within the categories, you can see what topics those sections encompass. So in order to do this, I devised a two-step interview process. The first interview, I got introduced to all the current projects of each project scientist and postdoctoral researcher in the space crop production program. And then in the second interview, I assigned gaps to those projects. And then I quantified them in the charts here on the right, as you can see. And it's pretty evident that crops has the highest density of gaps. And this is mainly because this section encompasses many plant growth factors for all the candidate crops for spaceflight. And BPS is the main benefactor of the space crop production program, and they are interested in these topics because they inform fundamental biological knowledge. So I believe a measure of scope within the gaps list ensures understanding of the amount of time and support necessary to close each of these gaps. Now, the lowest section was hardware, and I believe this is because the space crop production program is shifting toward needing hardware for larger scale production. And so I believe a measure of priority within the gaps list would draw attention to these pertinent gaps that aren't quite being focused on yet. And the moderate section was ecosystem, but this section had the highest number of gaps with no representation at all. And that's because many of the gaps in this section are complicated and depend on multi-factor interactions. So I believe a measure of dependency within the gaps list will draw attention to gaps that must be completed before others can be completed. Overall, I found that the gaps list method is effective, but the gaps list was out of date. But we believe that an efficient rate of progress will likely be achieved if adequate support is given to all sections of the gaps list and if the following recommendations are implemented. First, a measure of priority. It might be great to create a new list that measures the priority of each gap, which one is more important than the other. Also, a roadmap that measures dependency and the gaps that must be completed before others. And then changing the wording of the gap descriptions to include scope so we can understand what kind of time and effort it will take to close the gap. And lastly, the gaps list must be reevaluated at regular intervals to ensure congruency with the current research questions. Thank you so much. My mentors and co-authors for this project were Joy Massa and Ralph Richsky. And thank you to all the interviewees at the Space Crop Production Program. And lastly, thank you to the North Carolina Space Grant for funding my internship this summer. It was really fun. And I hope you guys enjoyed my presentation.